It's kind of a classic lab
clumsy.
in college.
Okay,
or AP chemistry too, or whatever. Okay, hey, same type problem, except we don't have a balanced equation.
Okay.
Some of you still, I bet, are still struggling with writing a balanced equation, and that's just part of it. You've got to go back and put your charges together, but you know you're going to get good at it because you're going to get to do it the rest of the year. Okay, so lithium. I have a lithium story. No, you don't.
No, you have a potassium.
No, it was lithium. A friend of mine.
Another.
He was an environmental.
Alkaline metals.
He was an environmental engineer at Rocky Ford Nuclear Weapons Facility, and for some reason they used lithium in that process. And he was investigating the lack of lithium in their storage, and discovered that a couple of the workers had taken a big hunk of lithium, like this big, and thrown it into the lake.
Oh, I bet that's fun.
Yeah, and I guess it blew up, and it was very exciting, and they were bragging about it. Long story short, they got fired. So
yeah, that tends to happen when you steal
basically
things from
steal
work
explosives.
And, yeah.
Lithium explodes, and like you steal explosives. Yeah, those guys lost their jobs. Okay, so he was telling me that story. They didn't like him for that. Okay, lithium. All right, so lithium is just Li. Reacts with copper 2 phosphate. So copper is Cu plus 2. The Roman numeral is the
charge.
Always the charge.
Charge.
Phosphate. If you end in an 8 that's got some oxygen in there, that's a PO somebody.
PO4
4
minus
negative
3.
3. So when we put those together, that's a really weird one. Cu3 PO4 2. Now, it doesn't tell us... Well, actually, it does say. It says 1.2 grams of copper is actually formed.
Okay, so that's product.
So we know
Cu.
it's going to be copper, but then it's going to get together with
Single
lithium.
Replacement reaction.
So we have to write lithium and figure out his charge. His
Plus
charge
1.
is plus 1, reacting with a negative 3.
So we need 3 lithiums.
So you say Li
3
PO4.
Yeah.
Now we go back and we balance the equation. Complex guy is this one right here, so we'll leave him here. So let's do the copper first. 3. Put a trace there. We got 2 phosphates, so if I put a 2 here, and this gives a 6 over here.
All right.
Now, what do we know?
We know 23.4 grams of copper 2 phosphate and 15.3 grams of lithium. Ooh!
15.3 grams here.
Interesting.
Oh, I know. I see. Did I throw this one at you, Mr. Sams?
23.4
grams. And we get 1.25 grams.
We have 2 reactants that both have a mass.
So,
this is a limiting reactant.
And a percent yield problem.
And a percent yield problem together.
So, guys, what we're going to do is we're going to convert grams of copper phosphate to grams of copper. And then grams of lithium to grams of copper.
Yep.
The lowest one will win, but then that will be the number. That number needs to be larger than 1.25. In theory. I guess it still could be. We could more than 100%, but that's not going to happen.
Yeah.
I think we're doing problems always like that.
Yeah.
And then we'll divide to find our percentage of yield. So we have to do a gram-gram problem.
If you can do this problem, guys, you can do
Then you are
anything
amazing.
in this unit. You are good to go because you can write and balance an equation, you can do limiting reactant stoichiometry, and you can do percent yield.
Except for the molar mass one, but that's okay.
Well, that's coming
So
next.
grams of Li to 1 mole of Li. 7.
7.
Is it 7.0 or 6.9?
It is 6.941.
So we'll call it 7. No, 6.9.
6.94.
Well,
we want 3 6.
Well, we just go to the 10th. Of the
Okay.
decimal. And then we're going to say, what do we say? 6 moles of lithium to 3 moles of copper. And then we're going to say 1 mole of copper to 63.5.
Copper.
63.5
Yeah.
grams of copper. And I get what, Mr. Sams?
70.4.
70.4 grams of copper.
Okay.
All right, so now we're going to take
Next.
the 23.4 grams of Cu3. I'll write this 100 times. 4.2. I guess I wrote the problem. Okay. And then I'm going to say grams of Cu3, PO4, 2. That's going to be pretty complex in terms of its molar mass. You'll have 3 times 63.5 plus 2 times 31 plus 4 or 8 times 16.
Can you do that in your head?
I don't know.
380.5.
380.5. I should have saved more space there. And then we're going to say, 1 mole of the Cu3 PO42 to 3 moles of copper. One more step, and I'm going to say there are 1 mole of copper to 63.5 grams of copper. And this gives me what, Mr. Sanders?
That is 11.7 grams.
11.7 grams of copper. Well, the lower number is 11.7,
Yep.
right? All right, so I'm expecting to make, here in my copper right here, I'm expecting to make 11.7 grams because that's the limiting reactant. But
Yep.
I only made 1.25 grams. Not a very good yield, really.
No, not at all.
So what would you do? Well, you'll take 1.25 grams divided by 11.7 grams times 100.
10.7%.
Or no, I mean the unit is percent on this one, okay?
Yeah.
Okay, so if you can do these two problems, again, let's kind of go back and just do a quick review here. There we go. Okay, let me change the color of the pen. I think it will highlight it better for us all. If the pen would like to go in color, let's go red. Okay. You're going to convert the grams of the lithium, of a reactant, let's just say, to the grams of the product. If you've got two of them, you got to do both. The lowest one, which turned out to be the 11.7, it was the lowest answer. But then you take the amount that you actually got, and you divide it by the amount that you got, and then you times it by 100.
Yep.
That's how you do percent yield problems. Good? All right, we'll see you in class. And no more playing with the lithium or yielding. You need to yield more on your car, don't you? Is that what it
I
is?
just need to slow down.
Just slow down. Yeah, that's probably too. All right, especially today. There's like ice on the road.
Uh-huh.